or I may find a use for, we may have to wire to the reverse. I could have the phases swapped on the controller and the motor turning in the wrong direction. Actually, most of this doesn't care if it's in forward or reverse direction, so we could change from wiring our pin 16 to pin 7 for drive and wire it to pin 8 instead for reverse. So all this has to remain accessible because we may make some changes to it. Certainly when we get into the software configuration, there'll be changes. And so that's pretty much what you're facing. This is one of the biggest challenges for the mechanically inclined, but if you can configure your preferences on Microsoft Word, you've got the tools to do this. Making the connector, you might get somebody with a little bit of electronics experience to show you the first few wires, but after you get it, it's very simple. We have run into people trying to improve this, oftentimes the knowledgeable. Too much of a little bit of knowledge can be a problem. These use crimp connectors. There's a reason they use crimp connectors. A lot of people like to put the wire in there, crimp them down, and then solder them so it'll be real good and tight. That's not a good engineering practice, and here's why. This little pin, you're right, it's not entirely secure on that wire. It kind of slips back and forth and gives a little bit, and you might even be able to pull it out. It seems like you ought to do something more. Solder, of course, is a kind of a melted metal. Started with lead. They don't use lead so much anymore. Tin and silver. And you can get that wire connected to it really good at the pin. Problem is, the solder wicks up the wire under the insulation just a little distance. And at that point, you have a flexible wire and a stiff metal part that's solder. And as that vibrates and moves around, you've just set up a point to break the wire off. On these automotive connections, it's actually better to use these crimp pins, and you have contact. You want this to be down tight enough to hold the wire against the normal stresses of plugging and unplugging it. But this is going to go down the road vibrating 20 times a second for the next 11 years. And you're going to break off a soldered connection. That's why these apparently inexpensive looking plastic connectors with these cheap crimp pins look like somebody is saving a lot of money on this. That's not the case. They're designed specifically for automotive applications because they need a little give to them. And that's because they vibrate. As long as that wire can flex and slip around inside that pin, it'll actually maintain good connection. But if you solder that wire to that pin in an attempt to do a really good job of wiring, you've just created a break point, and it'll break within a few months typically, but certainly within the first couple of years. So while it may make you feel good and look good, you've actually made it less secure, not more. Most connectors connector design is an art form. I guess I could say I've never seen a connector I liked. Neither has anybody else, but they work on them constantly. Amphenol and a number of these companies work on connector design. They've got a whole team of engineers working on that all the time. They have to be something that's configurable, that you can add pins and remove pins, but it also has to be able to endure thermal stresses, vibration, weather, a number of things, humidity that are simply hard, and just insertion and plugging and unplugging them multiple times. So it's kind of it's a very mundane area of electronics design, but actually a pretty rigorous one. And so I like to use good connectors. As I say, I've never really met a good connector. The search is always on. But these automotive style connectors are built in a specific way for a reason, and the best thing you can do is get the instructions sheet on them and do it as closely as you can to the way they do it, because there's reasons for every bit of the process. I kind of cheat, don't use that crimp pin tool. You probably ought to. We'll do some more on cable connections and so forth in a bit. More generally, I don't want to turn this into a basic electronics and electricity course, but I thought I'd mention some of the things, some of the options that you're going to run into wiring this particular controller. And most of this applies to all of them. You're always going to have a control connector on any controller you get, and you're going to have to wire it up pretty much from scratch, because they don't know how long the wires are going to be in your car or what you're wiring into, and there's a lot of options to it. So I hope that at least gives you some things to think about, and shows you a little bit about what we're doing to mate this controller into the Mini Cooper. That's a process, not a task. We're going to get it basically mated in, get the car running, and then we've got some signals like that ABS signal, the TAC signal, and so forth, that we're going to be chasing for some while. Every time we get the opportunity to marry it in a little more closely with the electronics in the car, which we don't know a whole lot about, we're going to take it. So for now, we're going to try to get it rolling with a basic connection, and that's kind of the plan. Okay, Brian. We've got some kind of mixed results here.
Well, we do have results.
I've been working on this a little bit. Our accelerator, using the power supply out of the DME,
Okay.
it just wasn't put down enough to drive our controller. I've been working on wiring up our control plug to the traction inverter module 600 from MESDEA. So what I've done is taken the 5 volt and the ground supply from there and gone back to our DME plug. Let me see. I've got the pins here. Pin 20 and 46 out of here.
Out of here, okay.
Are redundant 5 volt supplies to the accelerator.
Okay.
And 44 and 47 are redundant grounds. So I've wired those up.
Found those.
I've got our accelerator working. This is just a little laptop with a USB to serial cable. And of course, we'd wired in our RS-232 connection into this control plug. The wires look a little mess right now. We'll put a shroud and stuff around them eventually. This has got some software that comes with the TIM 600. And it looks a lot like something done by a 6-year-old with a reduced basic instruction set. Apparently in Switzerland, software hasn't caught up
Hasn't
yet.
quite caught up with the rest of the world.
I hate it that all these control programs run on Windows. I like Linux, Mac OS X. I've kind of grown beyond Windows and no longer interested in the whole virus pop-up issue and Bill Gates and his whole thing.
The whole thing.
But I have to run them for these little setup configuration programs. When I say something's programmable, I don't mean you have to learn C++. A little configuration program they put to connect with the controller over the RS-232. Same with the eVision. Same with everything.
There's a lot of that stuff, yeah.
And so that's what we've done. I've got the pedal hooked up. You remember when we were talking about balancing the flywheel?
Yes, yeah.
We should talk about that some more.
We're going to have to balance the flywheel.
I've got her spinning. We've got her up on jack stands. We're going to spin the wheels for the first time on the Mini Cooper, but it's not all good.
All right.
Why don't you go stick a stick on the We don't have a seat in the car, so
Yeah, I'll
he's
get
going to
it.
have to press the accelerator pedal with a aluminum stick. The good news is, I suppose, the TIM 600 actually has a lot of configuration parameters.